Pre-calculus lesson 15. What we're going to be doing is looking at x squares, x cubes, x to the fourths, x to the fifths, and we could go all the way up to x to the hundredths if we wanted to. We're just not going to make it that big. It gets challenging. What we're going to talk about is end behavior. End behavior. We'll talk about what that means in a minute. We're going to find the roots or the zeros. In other words, we're going to solve. If it's an x square, how many roots does it have? Or how many zeros? 2. If it's x to the third power, 3. X to the fourth power, 4. Okay? We want to determine whether the graph bounces off or crosses the x-axis at each root. So we need to talk about that. And then we need to find the y-intercept. And then we're going to sketch a rough graph. All right, I'm going to do these in color. End behavior. Here's what we've learned in Algebra 1 in working our way up. We learned in Algebra 1 that the parent function of a line y equal x looked like this. Okay? We learned in Algebra 1 that y equal x squared looks like this. Yes. You learned in Algebra 2 that y equal x to the third looks like that. You might have actually gotten it in Algebra 1 also. And you probably learned in Algebra 2 that y equal x to the fourth looks like this again. Now that's enough to learn the pattern or the rule that applies to end behavior. Might get a little congested if you do it here too. You might want to put that on notebook paper, those rules, or it may be that you can just watch and soak it in, but I do need to have them videoed in case you need to see it again. So what are we seeing here? If there is an odd exponent, then the end behavior is going to be an up and down situation. If the exponent is odd, one wing points up and one wing points down. Now, that's if it's odd and positive. What if we made that a negative x? What would the graph look like? That, correct? What if it was a negative x cubed? What would it look like? That, correct? So my end behavior if there's an odd exponent is like that if it's positive, but like this if it's negative. It's still got an up and down, but remember, lines with positive slopes lean to the right, and lines with negative slopes lean to the left. And that same idea applies to the third power, fifth power, seventh power, ninth power, all odd powers, okay? If there is an even exponent, the end behavior is an up-up. It's an up-up if A is positive. But if we made that negative x squared, then it would open down instead of up, so it would be a down-down. Okay? Does everybody understand end behavior? Let's review with the words. If the exponent is odd and the leading coefficient, which is a generally, is positive, then there's one up and one down, but it leans to the right, as in the way that a line would lean to the right, the end behavior. If there's an odd exponent and a is negative, then there's going to be one up and one down, but they would lean as if there was a line leaning to the left, your end behavior. If there's an even exponent, we're talking about the exponent like second power, fourth power, sixth power, eighth power, then it's going to be an up, up, or a down, down. But if the leading coefficient, which we generally call a, is positive, then it's going to open up. Or if that leading coefficient was negative, it would open down. Everybody understand the end behavior rules? So that's what I've got underlined in green here, end behavior. We have to determine that first, end behavior rules. And if you look here, it's going to say circle the correct end behavior. We've only got 4 choices, you see. One up and one down, but leaning right. One up, one down, but leaning left. Both up or both down. That's their only 4 choices for end behavior. Okay? All right, everybody understand that? Part 1. The next is to find the roots. Well, the roots are the zeros. The roots are the values of y, the values of x when y is 0. So the roots are the zeros, and we're going to find those by some factoring method, and we're going to learn a whole lot more about factoring soon. We could use the quadratic formula, but you can't use it on an x to the 3rd power, or x to the 4th power, or x to the 5th power. You can only use the quadratic formula on a quadratic, which is x to the 2nd power. So we're going to be forced to learn some factoring techniques. Okay? Any questions on what I had underlined in red? We'll do more of that. Okay? Now, tell whether the graph bounces off or crosses at the x-axis. Here's how we know that. At each root. We want to know if at a root it bounces or crosses. See what we're talking about right here? If a root, if one root, a single root, appears an odd number of times, it will cross at that root. Now remember, a root is an x-intercept. It's where it hits the x-axis, okay? And if that root appears an even number of times, it will bounce. Bounce. Now, I'm going to help you understand that just a little bit. With just a little bit of information. Has everybody got that written? I'm going to give you time to write it. And because I want you to be able to concentrate on what these examples I'm going to give you so that you can have some idea of why that's a rule. Okay? Bounce. Bounce. Look in the typed in the blue circle oval. We're going to bounce or cross at the root. Okay, let me show you the idea that we have. If we were going to graph a line and we had an x-intercept, what's going to happen when you graph the line? It's going to cross at that point. What if we had a parabola that had it had 2 different answers on a quadratic? That tells me that quadratic is going to dip under and come back up, right? What if on a quadratic there was one answer that appeared twice? You remember that happening? What was the situation when we solved a quadratic and we had identical twin answers? We had identical twin roots. we said that that means that that is setting on the axis. You remember that? Now, this is the idea of bounce. And this is the idea of cross. When did it bounce? When you had two of the same. 2 is even. 1 is odd. And if you played with this enough, you would realize that if a particular root appears an odd number of times, it's going to cross at that root. And if a particular root appears an even number of times, it's going to bounce at that root. Okay? So there's our rule. If that root appears an even number of times, it will bounce. If that root appears an odd number of times, it will cross. Okay? We're going to see that happening in a minute with the problems, and it's going to be even more real to you. Okay? So we've talked about end behavior. We've talked about bouncing and crossing. Then it says find the y-intercept. Well, we know how to do that. To find the y-intercept, you let x equal 0. So we know how to deal with this whole thing. Okay, we know how to deal with each piece. So now we can start doing problems. Has anybody got that written down that needs it? Any questions before we continue? Okay. All right, so here we go. We want to determine end behavior. So we think, is my exponent odd or even? Even. I've got an even exponent. That tells me that I'm either up, up, or I'm down, down. Do I agree with that? If the exponent is even, I'm either up, up, or down, down. If it's odd, I've got one up and one down. Now, how do I tell if it's up, up, or down, down? The leading coefficient is a positive. Therefore, I'm up, up. Everybody understand that? So my end behavior is an up, up. I knew they were the same because it's an even exponent. Both up or both down. The leading coefficient A was positive. That tells me that they're both up. Any questions on how we got the first part? Okay, so we've dealt with end behavior. Now it says find the roots. So we're going to factor this quadratic. And lucky for us, A is 1. So they, being me, made it easy. Unless we pulled it out of another book, and then they made it easy, and I borrowed it, or made one up exactly like it. Anyway, so if A is 1, which it is, then we know that we can just go ahead and put our parentheses and put an x and an x. We're going to let y be 0, right? To find the roots, they're the values of x when y is 0. Now, how do you know I put too many of those? Because the next square has how many roots? 2. I made enough blanks for how many. There's only going to be 2 roots, right? Sorry about that. I wasn't paying attention. I was just filling in zeros. All else fails, read the directions. Okay, so we're going to have 2 roots. Now, if A is 1, we think, what do you multiply to get the C value of negative 10 and add to get the B value of negative 3? And the answer is, well, the factors of 10 are 1 and 10 and 2 and 5. 2 and 5. We need a negative 10, so they need to be different signs. And I need the larger to be negative. They need to be different signs to give me a negative here. The larger negative to get a negative 3. So I've got plus 2 and a minus 5. I'm saying, what can we do? What will multiply? M for multiply. What will multiply to give me my C value and add to give me my B value? I just didn't want to write out multiply and add. Okay. Everybody say we got that. So we can say that either this first factor of x plus 2 equals 0, or the second factor of x minus 5 equals 0. And we'll spare the work here. You'd subtract 2 and get x equal negative 2. You'd add 5 and get x equal 5. So my roots are negative 2 and positive 5. So I found the roots of my quadratic. So we got that. Now I want to know if they bounce or cross. They bounce if there's an even number, and they cross if there's an odd number. The root negative 2, 0, does it appear an even or odd number of times? Well, there's only one of them. There's only one negative 2, 0. It appears once, an odd number of times. Therefore, it's going to cross at negative 2, 0. Okay? The root 5, 0 appeared how many times? 1. Is that an even or odd number? Odd. So it's going to cross at 5, 0 because that root appeared an odd number of times. Okay? Very good so far. Okay? But you have all that because I have to erase. Oops. I could have left that. All right. So we've filled out that much so far. Now, the y-intercept. The y-intercept is y when x is 0. So we would put those in place of x both places. So we would have y equal x, which is 0 squared, minus 3 times x, which is 0, minus 10. As we know, that's going to knock those out and get y equal negative 10. So we found all the stuff that we're going to use to graph this with. Okay? Wow. That's not good. That's recorded also. I think I said it right, put it in the wrong spot. The y-intercept is the value of y when x is 0. So we replace the x with 0, and we get 0, negative 10. Thank you. Sorry about that, video watchers. Okay. Now, we want to graph this, and y'all have got all the information. I'm going to have to move the graph, okay? So, what we know is that the roots are what? Negative 2, 0, and 5, 0. We know that there's a y-intercept of 0, negative 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, let everybody get that. Then we want to get our end behavior and our bouncing and crossing. We're not trying to draw a perfect graph. We want a general idea of what the graph would look like. Okay? Now, what's the end behavior? It was up, up. That means that this, you see that this point right here is the left outer extreme. Somewhere past that out here, there's going to be an up. We know that. So we're just going to make a little arrow over there. Somewhere it's going to be going up past that. And then this is my right extreme over here, and somewhere it's going to be going up past that. Now, we know that's going to be going on because of our end behavior. Yeah, we are, but so we hadn't gotten there yet. The question was, do you make the U shape? Now, we know since it's an x squared, it's a U, but when we get to those fourths and fifths, we don't know what it's going to look like. So we're acting like we don't know what it's going to look like yet, even though we do. Okay, now at this root right here to the left, what does it cross or bounce? Crosses. Okay? On the root to the right, did it cross or bounce? Crosses. So that gives us an idea that this thing is going to look something like that. Now, we already knew it was a parabola, and we didn't draw it perfect. If we wanted to draw it perfect, we would go back to page 195A to that little pretty table building agenda and do that. You see how we use that information to get a general idea of what that graph is going to look like? Now, you may say, well, we can do better than that with a quadratic, but what about a fourth power, fifth power, sixth power, seventh power, eighth power, ninth power? That's where this general idea of the graph is handy to know before you start trying to plot points. Okay? Any questions there? All right, so let's go to the next one. On the next, we have it to the third power. Now, we're going to begin with in behavior. When we look at in behavior, we look at the exponent. The exponent is odd. That means that there's one up and one down. Okay? They're not both up and they're not both down. There's one up and there's one down. Now, then we look at the A, the leading coefficient. The leading coefficient is positive. Remember, lines with positive slopes lean to the right, so it gives us the idea that my in behavior is this one instead of this one, you see? Because we think about the slope of a line. Odd stuff, odd exponents are kind of the idea of a line. And when the slope is positive, it leans to the right. So I'm going to have the in behavior of a line with the behavior of a positive slope on a line. Okay? Very good with that? Now we want the roots. How many roots are there going to be? 3, because it's x to the third power. So since it's x to the third power, we're going to have 3 roots, and the roots are the values of x when y equals 0. So we need to factor this cubic. Haven't done one of those yet this year. I needed to see the sign of my 2. Now, in this class, we haven't learned the complicated way to solve a cubic in finding possible roots and using synthetic division or long division. We haven't learned that yet. So the first ones I'm going to give you this year, you will be able to factor by grouping. Okay? So this test will not have any cubics on it that are not factorable by grouping. Factorable by grouping. We will solve all the, I meant cubics. We will solve all the cubics with the process of factoring by grouping on this test, because I'll have to teach you some more stuff before I put other stuff on the test. So we're going to factor by grouping. We're going to group the left pair and the right pair. Now we can do that because my exponents are going 3, 2, 1, 0. Okay? And there is common factors from the left pair and the right pair, and this particular cubic is one that will factor by grouping. Some will not. Okay? So they were specifically made up problems. Now, what can we factor out of the left pair? An x squared. You understand that? The smallest power of x in any numbers. So we're thinking x squared times what is x to the third? X, right? When you multiply with like bases, you add the exponents. X squared times what is negative 2x squared? Negative 2. So we factored the left pair. Factored out an x squared. Now we factor the right pair. What can we factor out of the right pair? A 4, but we need to take the negative off. Because that x inside here is positive, and we don't want the one inside there to be negative. They wouldn't match up. Okay? So negative 4 times what is negative 4x? X. Negative 4 times what is positive 8? Negative 2. Remember when we're factoring, we're hoping for a common binomial. If you don't get a common binomial, it's not factorable. That or you messed up when you was trying to factor. We did get a common binomial. That's good. When we go from there, we take that common binomial and we make it our first binomial. And then we take the pieces and make that our second binomial. And we're letting y be equal to 0. Let's see how we got that. A squared minus b squared is called the what? Difference between two squares. This is from Algebra 1 and Algebra 2. We have to recall a rule here. What does the difference between two squares factor into? Binomial. We already used those to fix the denominators of quadratics, of radicals and stuff. You multiplied by the binomial conjugate. Remember that? So the difference between two squares factors into a plus b, a minus b. Remember that? You need to remember it from now on. That's very important. So this is what? It's x squared minus 2 squared. You don't have to write over years. I just want you to see that that's x squared minus 2 squared. What's that going to factor into? X plus 2, x minus 2. And we still have this first x minus 2. Yes. But you have to recall, obviously, the difference between two squares. You have to recognize it and be able to factor it into the binomial conjugates it came from. So my roots, those are my factors. I got to find my roots, right? If it's x minus 2, what's the root? Positive 2, right? Because you'd put it equal to 0. You'd have to say x minus 2 equals 0 plus 2 plus 2 x equal 2. Okay? So if the root is x plus 2, then what's the factor? Well, if the factor is x plus 2, what's the root? X equal negative 2. If the factor is x minus 2, what's the root? X equal 2. So my roots are x equal 2, x equal negative 2, x equal 2. Everybody understand how we found the three roots? We did a factoring by grouping, and then we recognized the difference between two squares. Now, the root 20 appears how many times? 2 times. Is that an odd or even number? It's an even number. That means that it bounces at 2 because that root appeared an even number of times. How many times does the root negative 2 appear? Once. That's an odd number, so it crosses because that root appeared an odd number of times. So we're going to bounce at 2, cross at negative 2. Okay? You may be thinking, does it bounce up or down? You'll have to figure that out with all this other stuff. Okay? All right. We want to find the y-intercept, and the y-intercept is a value of y when x is 0. We're going to put it in the right place this time. I'll just show the work up here. We're going to put a 0 for x in 3 places, correct? So we would have y equals 0 cubed minus 2 times 0 square minus 4 times 0 plus 8. And we've got it figured out already that all that's going to just wipe out, and it's going to be that 8 out there. We probably already know that, but oh well. There's the work. If you plug in a 0, it knocks out everything with an x, and the only thing left was that 8 out there. Okay? So we know the end behavior is up, down, leaning to the right. We know it bounces at 2, crosses at negative 2, and the y-intercept is positive 8. All right, so we're going to get an idea of what this thing's going to look like. Is everybody good there? All right, so it had the roots of 2, 0 and negative 2, 0. It had a y-intercept of, are you noticing the order I'm getting all my points on there before I do all the end behavior and the crossing? Because we got to figure out where the thing's going before we can kind of put our little arrows, okay? Okay, so the y-intercept was 0, 8, up 1, 2, 3, 4, 5, 6, 7, 8. The end behavior is down on the left and up on the right. So here we go. This is my extreme left point. So somewhere past that, there's an arrow down to the left. You understand that? We don't know exactly where it's at. We're not trying to be in exactly right spot. We're getting the general behavior of this graph. Now, the extreme right is here, and somewhere beyond that, there's an up and to the right. There's my end behavior. Somewhere out there, that's going on. Okay? Now, at the root, negative 2, does it bounce or cross? Crosses. It appeared an odd number of times. It crosses. Now, at the root 2, does it bounce or cross? It bounces, right? Because it appeared twice. Now, don't write this down. Your mind may be thinking, does it bounce up or does it bounce down? Well, look where this other point is. And look where my end behavior is. If it's going to bounce off of this and go to this and this, it has to bounce up or it's not going to hit them. You see how you figure out if it bounces up or bounces down? So I'm going to have to bounce up to that and bounce over to my end behavior. This thing obviously turns and comes back down to here, and this obviously connects. So that gives us a general idea of what the graph of that cubic is going to look like. Okay? Any questions on that? These are cool problems, aren't they? Isn't this neat? We're graphing all kinds of silicon stuff. Now, let's put that thing on the graphing calculator real fast, just to do one. If we put that in y equal, what was the equation? Y equal x to the third plus or minus what? That was weird. Raised to the third. And then what minus 2x squared minus 4x plus 8. If we graph that thing, we should get what we did. Okay? Yeah. So you can plug it in the graphing calculator and get that idea. But we see we got that general idea from just the things that we did on paper. Okay? Any questions so far? All right, we'll stop there and create a part 2 or 3 or however long it takes. All right.